It looks clear overall. Let's take a look out at the live shot of our pad and the rocket, and you can see there it is, looking beautiful in the light. Just a note for you, in the upper left-hand corner, there's the L- time, L- 19 minutes and counting. Across the bottom, the progress bar, you see we are in a T-4 hold. More on that in a bit. But we're talking weather now, as you can see, clear through the dark. This is so that ground teams and launch teams can see what's going on with that illuminated pad and monitor what's happening around the rocket. Let's talk more about the weather. And yeah, we had a little bit of rain earlier, Will Ulrich, our launch weather officer, but overall this is looking fantastic from a forecast perspective.
That's right, Daryl. Really, all things considered, we couldn't be asking for better weather early this morning. Those sprinkles that you mentioned have since cleared the area, and now all we're left with is partly cloudy skies and light winds, thanks in part to an area of high pressure that remains dominating over the southeastern United States. A live look at satellite imagery behind me shows those mostly clear skies across much of the state, and that's going to make for a great viewing opportunity, regardless of whether you're watching in Jacksonville, Tampa, Orlando, or locally right here in the Space Coast. My colleague Jessica Williams just gave her final weather brief at L-30 minutes to United Launch Alliance, Eastern Range, and NASA officials, and gave a greater than 90% go for weather, so we are not tracking any issues at this time. As a reminder, my colleagues and I are here to ensure that the weather is safe for launch, and we do that through the evaluation of 10 lightning launch commit criteria, which are designed to protect against both rocket-triggered and natural lightning. In addition, we also monitor user weather constraints like surface wind speed and precipitation. And while things are looking really good for launch this morning, should we need to utilize tomorrow's backup window, we do anticipate conditions deteriorating as we see a cold front move through the region. But let's not worry about that right now, because conditions are looking great. Mother Nature is giving her thumbs up, and I'm happy to report that the 45th Weather Squadron is go for weather. Daryl?
Great update about the weather outside. Thank you, Will. We are currently L-17 minutes and counting until liftoff. Asteroids are prehistoric treasures that hold the lost stories about our origin of the solar system. Here's what else you need to know about Trojan asteroids. This mission is such an incredible opportunity and one of the many missions aimed at asteroid research right now. Let's head back out to NASA's Megan Cruz, who is with the head of NASA science missions. Megan.
I am, Daryl. Joining us right now is Dr. Thomas Zurbuchen. He's the Associate Administrator for NASA's Science Mission Directorate. Good to have you here this morning.
I'm so glad to be here. What an exciting morning.
It is, and I'm so glad you're here because I got to ask you a question. You know, first off, tell me a little bit about the Science Mission Directorate. What's the goal there?
Well, so we're the organization at NASA that does all science, you know, and it, of course, is planetary science, just like we're launching today. It's also astrophysics. I just got a picture of the James Webb Space Telescope that in the crate there in Kourou getting ready for launch, and then it's the earth science, heliophysics also biological and physical sciences. That's all the science we do at the agency. Just an amazing amount.
Yeah, and when you became associate administrator of the Science Mission Directorate, Lucy was the first mission you selected. Why is that?
Well, so the timing was there. We had 5 mission candidates, and I have to tell you, it was the first. It's one of these amazing decisions, and of course, many people helped with that. But I looked at this, and this orbit and the science was so compelling. I said, we gotta fly this.
Yeah, the trajectory is amazing. I mean, the fact that we've been able to figure out how to get to the Trojan asteroids in relatively a short amount of time. What do you think about that?
Well, I mean, it's so innovative, right? I mean, we actually, the science community had said, we want to do this, but we want to spend $500 million or $1 billion more than this team proposed. It's like, this is good money. Let's go do this. It's really innovative. Absolutely.
And how does Lucy tie into NASA's overall asteroid research that's going on right now?
Well, we're really starting a decade of asteroid science, right? We're launching in 23. OSIRIS-REx is bringing back the samples of Bennu down kind of in Utah. We'll come down there. Next year, we're going to be here again and launch Psyche. And just later this year, we're going to launch DART, which is the first collision experiment trying to really deflect a potentially threatening asteroid. You know, so for us, it's many parts. And of course, at the heart of it, Lucy is just absolutely a mission of discovery. Yeah,
we're really doing a lot of amazing things, and I think that you have a lot to do with that. So thank you so much, Dr. Zurbuchen. I really appreciate you being here today.
Appreciate it, Megan. Thanks so much.
Awesome. Daryl, back to you.
All right, thank you, Megan. And we're just seconds away from the NASA Launch Manager poll, so let's get out to Joshua and Mick to pick it up. Guys?
Hey, thanks, Daryl. Yes, things, again, proceeding really well. Appreciate the report from Will Ulrich, because the weather is always the other side of the coin, right? We got the launch team in the technical. We got the weather in good shape. As you see there, the rocket venting and having the condensation appear around the rocket as we would typically expect. So everything healthy and on track. Like Daryl just mentioned, we will hear from Omar Baez, the NASA Launch Manager. He'll be polling the NASA team so that he can in turn report out on the ULA Launch Conductor poll that will happen a few minutes later. So that should happen right here at L-minus 13 minutes. Let's listen in for that now.
This is the NLM on the NLMnet, just providing an update. The range did notify us that one side of the JDMTA command site.
Hey, so let's go ahead and we're going to step away from that for now, and we're going to, obviously there's something developing there. We were expecting to get that poll, and so we want to be respectful of what's happening there. The technical data, we're not sure that that's going to be approved for release, so obviously we'll be standing by to pay attention to that and give you updates as we understand more, but do want to kind of get back on track with talking about the, we are hearing that we think Omar is going to pick up with this poll. Coming up now.
NASA CE, go.
SMA?
SMA, go.
SMD?
SMD, go.
NASA Mission Manager?
NASA Mission Manager, go.
LSP?
LSP is go.
Copy that. The NASA team's ready to release the hold at T-minus 4 minutes.
Yeah, so Joshua, what we heard there from NASA Launch Manager Omar Baez is he was basically just briefing his NASA team and spacecraft customer of an issue that the team, that the range had notified them of with one of their downrange assets. It looks like it was partially mission capable today. The team accepted that, and they are ready to move forward, as you heard in the poll, that all systems are go for the NASA side. And we'll be picking that up as Launch Conductor Scott Barney does his poll here in a little bit.
Yeah, always a lot of things in play. We will continue to track that. Again, a great sign that the team was able to work through that and improve to move forward. So we'll be back in a few minutes bringing you the final steps of the countdown and a report up as we transition Lucy into internal power. But for now, Daryl, back to you.
All right, thank you, Joshua and Mick. Lucy is going to visit as many asteroids in the faraway belt of Jupiter as we've ever discovered for near-Earth asteroids. And to get there, Lucy will need the right rocket and the right trajectory to carry out this historic mission. We headed out to ULA's Vertical Integration Facility, where inside we were awestruck after walking onto a platform 18 stories above the ground, because just a few feet away was the Lucy spacecraft, inside its protective fairing and on top of an Atlas V rocket. ULA was making final preparations to roll this entire launch vehicle out of the vertical hangar we were in and onto the launch pad. Jermaine Oliver, good to see you, my man.
Good to see you too.
Hey, thanks for coming out here and telling us about this flight trajectory and all the fun facts about Lucy going up into space.
It's my pleasure.
So, Jermaine, you are a flight design analyst with Launch Services Program. You know this flight pretty well. Tell me first about why we're launching at this specific time of year.
We're trying to rendezvous with two different sets of asteroids that are on the Jupiter line, Jupiter orbit. So in order to do that, you have to launch at a particular time to line up where the asteroids are going to be at, because if you don't, you'll either get there too early or get there too late.
Can you believe how close we're standing here next to the spacecraft?
I've never been this close before. This is great.
Let me ask you about this fairing. What's its purpose?
The fairing purpose is to encapsulate the satellite throughout the time it's going through the atmosphere until it gets into space.
So let's talk a little bit about the orbit. So this spacecraft is going out 530 million miles away from the sun. That's far, and it takes a careful orbit to get there.
Yes, what happens is you have to use Earth gravity assist to slingshot yourself to each of the different asteroid Trojans.
So Lucy weighs about the same weight as a mid-sized vehicle, 3,400 pounds or so.
Yeah.
So it's pretty heavy. What kind of thrust does this rocket need to get it up off the ground and into space?
Max thrust on this particular rocket is about 930,000 pounds of thrust, and to get Lucy on a trajectory that's going about maybe 27,000, 28,000 miles per hour.
Tell me about this rocket configuration, the Atlas 401.
It's just a 4-meter fairing that works great for this mission because given the spacecraft's weight, about 1,500 kilograms, and where it's going, the energy that it's going to, this particular rocket fits perfectly with it.
I'm really excited about the journey as it begins right here, right now, with this entire rocket and spacecraft rolling out to the pad. That's pretty cool.
Yes, it is. I've never seen it before, actually. I'm excited to see how this goes today.
You want to jump on and ride with the MLP?
Oh, no, thank you. I'm fine. Thank you.
Pass on that?
I'm okay.
Okay. Oh, look there. It's moving. Check it out.
Wow.
Well, Lucy's journey has begun. Isn't it amazing?
Yes, it is. Lucy's on her way.
Jermaine Oliver with Launch Services Program. Thank you so much for being here.
Oh, it was a pleasure being here. Thank you for having me.
And as that rolled out, we had to take some pictures and even a selfie because, you know what? I feel like we're the last people to be that close to that spacecraft going so far away.
Yeah. I mean, and few people get to be at the base of the pad. Even fewer get to be inside the VIF, especially at that moment of rollout. So that was a really cool opportunity that you had. All right, we are inside of L-8 minutes and coming up on the launch conductor poll shortly. So we want to hand it over to Joshua and Mick to take us the rest of the way through the countdown. Joshua?
Hey, thanks, Marie. I would love to say that rocketry is a team sport, and that's what we're going to get to kind of hear with this launch conductor poll in just a minute. 4 major teams that play this morning. NASA Launch Services Program responsible for the launch. United Launch Alliance providing the vehicle, the ride to space. We have the Southwest Research Institute, the NASA's Goddard Space Flight Center, and Lockheed Martin, part of the Spacecraft team, and then the Space Force.
Yeah, Joshua, we're very happy to have Space Force here as they protect the range and look at the weather. They're also responsible for vehicle and personnel safety today.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion.
Behind.
Go. Pneumatics. Go. LO2. Go. LH2. Go. HASGAS. Go. Electrical systems, airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operations support. Go. COM. Go. Umbilicals. Go. ECS. Go. Red line monitor. Go. Quality. Go. Ops safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 0934 Zulu.
Verified.
So Joshua, a very successful poll there by launch conductor Scott Barney. As you also heard, we verified that T0 is set for 0934 Zulu time. That's 5:34 local. Very happy to hear everybody green and go, and in particular, our friends at the range there, our Space Force friends, gave a clear for the range today. That's awesome. They're doing their job not only with weather but the safety. We also heard a little earlier in the count this morning that the range reported there are no COLAs this morning, which are collision avoidance assessments. So we are good for our first initial part of the launch window this morning, 5:34.
All steps are complete prior to terminal count.
Yeah, big thanks to the Space Launch Delta 45 folks for all their support. So looking ahead to terminal count, we just heard the call that the spacecraft is configured for flight. That includes being transitioned to internal power. And then, like I mentioned before, the next few steps are all about getting the launch vehicle and the spacecraft able to live on their own. So those are the things coming up here. We do have this release of the built-in hold. The eagle-eyed viewers that can see behind us might have noticed that there's a clock sitting at T-minus 4 minutes and holding. It's been that way for our entire show so far. That will then sync up with our L clock you see on screen at this moment, and those will count towards 0 together. Again, everything looking great for liftoff on time here at 5:34.
Yeah, Joshua, as we come out of this hold, what's very impressive this morning is this Atlas 401. We heard Jermaine talk about it. It's a 401 configuration, a 4-meter fairing, 0 solids on it, and 1 single Centaur engine on the second stage. This is a great configuration for the Lucy mission. It is the most common flown configuration by United Launch Alliance, and this will be the 89th Atlas V launching, so we're very proud of that.
2, 1, mark.
And there we go. The clocks are released, so we are ticking down here towards liftoff.
Ground pyros enabled.
Yeah, we'll hear the team securing a lot of their things, getting their final configurations in place, and making sure the rocket is ready for a T0 liftoff this morning. So the team will be working very quickly.
Yeah, and opposed to the missions that we might be used to with where we're hitting a low Earth orbit trajectory, this one is going into deep space, and so we'll be exceeding escape velocity of Earth this morning. So that's up and over 25,000 miles per hour. We know that over the course of Lucy's mission, she will get up to about 400,000 miles per hour. So very, very fast with all those Earth gravity assists. And for those that are in the physical area, you'll also notice that this rocket will take a little bit more of a southern track than we're typically used to seeing. We usually see rockets take off more towards the northeast. This one will move a little bit more towards the southeast than is typical.
Yeah, and with that southerly trajectory, people ought to be able to see some great things with the weather the way it is today.
3 minutes.
Atlas tanks to flight pressure.
Securing LO2 topping.
250.
FTS internal.
So there we heard the teams securing the topping and bringing the Atlas tanks to flight pressure. That's a huge milestone as we get ready for T0 this morning. The teams have finished putting LOX and hydrogen on board and making sure that all that 740,000 pounds of fuel is there for liftoff of Lucy. We also heard that the team brought in the flight termination system armed. That is part of the range safety that is needed for the vehicle as we lift off this morning.
Yeah, previewing what's to come ahead, so stay with us after liftoff. We'll be tracking with a couple burns of the Centaur, spacecraft separation, those beautiful solar arrays deploying, and then signal acquisition of signal will kind of be the end of our show for you today, beginning a 12-year, 4 billion-mile journey for Lucy.
Absolutely.
159.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
FTS armed.
90 seconds to go.
$120.
OCU's armed.
FCS count started.
$110.
Vent valves locked.
$1 minute.
Rock, report range status.
Range green.
All right, so stay with us again after liftoff. We'll also have the voice chiming in from Rob Kesselman from ULA. He'll be providing the launch vehicle ascent data.
$40.
Stable at step 3.
So that's a great sign right there, stable at step 3. Everything is at flight pressures. We're now the only thing left, Joshua, is that final status check with the whole team.
25 seconds.
Status check.
Go Atlas.
Go Centaur. Go Lucy.
Seven, 6, 5, 4, 3, 2, 1, 0. Liftoff. Atlas V takes flight, sending Lucy to uncover the fossils of our solar system.
Tower clear. RD-180 propellant utilization has gone to closed loop control. The vehicle has begun the pitch yaw roll maneuver. Now, 30 seconds into flight, vehicle is 0.6 miles in altitude, traveling at 939 miles per hour. RD-180 performance continues to look good at this time. Engine pump speeds and injector pressures are in family for this thrust level. Atlas vehicle attitude remains stable at this time. Attitude rates are near zero in all axes. Now at T plus 70 seconds into flight, vehicle is 4 miles in altitude, 0.2 miles downrange distance, traveling at 1,200 miles per hour. Mach 1, Atlas is now supersonic. Vehicle is now passing through max Q, maximum dynamic pressure. The vehicle is now throttling down slightly. RD-180 engine parameters continue to look nominal after the prior adjustment to the thrust level. Approximately 2 minutes remain in the Atlas booster phase of flight. The Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of 2,600 pounds per second. Vehicle is now executing closed-loop steering. Centaur reaction control system is now pressurizing the flight levels.
So beautiful launch sequence there. We do have another minute and a half or so to go with the booster in operation, getting Lucy.
We're now just under 3 minutes into flight. Atlas is 33 miles in altitude, 59 miles downrange distance, traveling at 5,600 miles per hour.
So Lucy being lifted up out of the atmosphere by the booster, getting on its way into a park orbit before we get towards...
All first stage vehicle systems are operating as expected at this time.
Future portions of the launch activity, we have the Centaur multiple burns ahead and spacecraft separation.
Yeah, the big milestone we should see, Josh, coming up is booster engine cutoff, which would be the first stage cutoff and then stage separation.
The main engine is now throttling to maintain a constant 5G acceleration limit.
We're going to see a few things happen pretty rapidly. The booster will cut off just after 4 minutes, and then within the next 15 seconds after that, we should see the Atlas separate from the Centaur, and then the Centaur engine ignite for its first burn.
Centaur has begun the boost phase chill-down sequence, and the RD-180 is now throttling to maintain a constant 4.6 G acceleration limit. Boost phase chill-down sequence has completed, and we have BECO, booster engine cutoff, and a successful stage separation event.
So what you're seeing on screen is an animation that's being driven by actual telemetry
data. Please start on the RL-10.
So we are watching these things in an animation happen here, but they're happening in real time as well.
And mess 1, we have ignition for the first burn.
All right, so there we go. We should see the fairing jettison here.
We have indication of good payload fairing jettison.
And there we go. All right, Nick, so that wraps up the first round of major milestones here. Still very much in the middle of dynamic flight.
The T system on the RL-10 is now in an open-loop burn-off mode to burn off excess fuel in the early portion of this burn.
So walk us quickly through, Mick, what are we looking for in this burn and the next one?
So this burn is going to end with MECO getting Centaur and Lucy into its park orbit around Earth. And then we will then get into MESS 2, which will get us into that transfer orbit, getting Lucy on its way.
Awesome. So that's going to do it for now. Finishing up the initial launch activities, everything sounding like it's going perfectly. Daryl, back to you.
Thank you, Joshua and Mick. A beautiful launch out here from our vantage point. Incredible. All right. Lucy was built at the Lockheed Martin facility in Colorado before arriving at the Cape Canaveral Space Force Station for launch. Engineers at Lockheed's Waterton facility use lessons learned from prior spacecraft like New Horizons and OSIRIS-REx to build Lucy.
And in July, Lucy was packed up and flown on board a United States Air Force C-17 cargo plane from Colorado to the Launch and Landing Facility runway at the Kennedy Space Center. From there, Lucy was transported to an Astrotech Space Operations Processing Facility in nearby Titusville for final preparations before liftoff.
Yeah, just a few miles from here before it was brought to the pad. For more about how Lucy was built, let's send it over to NASA's Megan Cruz.
Hey, Daryl. Yeah, right now I'm joined by Ari Vogel. He's the Deep Space Exploration Director at Lockheed Martin Space. How are you?
I'm doing wonderful. Thanks so much for having me.
Wasn't that just a beautiful launch? What did you think about that?
Incredible. You know, seeing it go over the clouds and brighten up the whole sky was just fantastic.
Yeah, to see it rise over the clouds, because, you know, we lost it a little bit because of some cloud coverage, but then it just rose out of it. It was so beautiful. And, you know, I really wanted to talk to you because your team at Lockheed Martin Space knew that you were going into a project that would require you to develop a spacecraft that would travel farther than any other solar-powered spacecraft ever. I mean, was that intimidating?
You know, it was a really exciting challenge to solve, right? And obviously, the most prominent feature of Lucy is their big solar arrays. Each one is about the length of a bus. And, you know, what we did is we basically just broke the problem down into smaller pieces and then applied systems thinking to make sure that the design trades we were doing didn't impact, or that we fully understood the impacts for over the 12-year mission. So, you know, being the farthest solar-powered spacecraft is certainly something that was difficult to prepare for, as is going to a record 8 asteroids in one mission. But that's why we have such a comprehensive Test Like You Fly program at Lockheed Martin, and we took it through the ringer at our facility in Denver.
Yeah, and you did it all within 14 months. That's during a pandemic. That's incredible. Can you talk to me about the challenges of that?
Yeah, you know, it's really awe-inspiring. I mean, to be able to build a one-of-a-kind spacecraft during normal circumstances is incredible. And the team just really pulled together, didn't miss a beat, connected and collaborated, you know, made sure that we didn't have any mistakes. And it really accelerated some of our digital transformation initiatives too, having to work during the pandemic. And not a single shift was missed during integration and test due to COVID. So team just did an awesome job, leadership with the preparation and the over-communication and the transparency. And then all the team, you know, just didn't let their commitment to Lucy waver. And I think the thing that I'm most proud about actually is that through it all, we still continued all of our STEM events, all our mentoring, our coaching, Lockheed Martin, NASA, Southwest Research Institute, hundreds of thousands of hours into that. So it was really, really a great job.
And really quick, you also built the antenna that's on there that's going to help us communicate with Lucy. Can you tell me a little bit about that?
Yeah, we did. 6.5 foot wide antenna that we built. Main job is to do the communication between the spacecraft. And, you know, it's also going to send back some of the first images of the Trojan. So the whole team is super excited for that.
Yeah, absolutely. Thank you so much, Ari. I really appreciate you being here today and for bringing Lucy to life. So thank you.
Thanks for having me.
All right, Daryl, back to you.
All right, thank you, Megan. And in case you're just joining us, we here at NASA are at the beginning of Lucy's 530-mile journey to the Trojan Asteroids beyond the sun, going to the same orbit, Marie, as Jupiter.
That's right. It was a beautiful launch here. We could see it light up the water behind us, and we actually had a gator in the water just behind us. Oh, joining us for liftoff. Yeah. Lucy is named after a skeleton fossil more than 3 million years old. Lucy was an early early human ancestor. And the Trojan asteroids are fossils, too, of how planets were formed.
Beyond the asteroid belt are fossils of planet formation, known as the Trojan Asteroids. These primitive bodies share Jupiter's orbit in two vast swarms, leading and trailing the planet. Now, NASA is preparing to visit 7 asteroids, embarking on a 12-year odyssey that will span Jupiter's orbit. One mission will explore these objects for the first time. Lucy, the first mission to the Trojan asteroids.
And another special guest that we had watching the launch from the Atlas Spaceflight Operations Center was none other than NASA's Associate Administrator, Bob Cabana. He is standing by with Blair Allen of NASA Edge. Actually, they're telling me that we lost audio with that group, so we will come back to that if we can, but while they try to work out their audio issues. But Daryl, we had a really unmatched view of launch here. It was just spectacular.
Yeah, it was incredible because we're sitting, you can't really tell, but this behind us is the Kennedy Basin, the turn basin where they brought in, the space shuttle main tank, as well as just recently the core stage for the Artemis rocket, which is in the VAB right now getting stacked. You're looking at the flight of Centaur and Lucy. We are L plus 11 minutes and 26 seconds as we cruise along, and we want to talk a little bit now about the message that Lucy is going to be sending.
That's right. Lucy is carrying something on board. Aside from her scientific instruments, she's got something a little more philosophical. There is actually a plaque affixed to the side of the Lucy spacecraft, and it contains quotes and messages from artists, poets, and thought leaders. And the plaque is meant to serve as a time capsule of sorts for our own descendants. You see, after Lucy's 12-year mission is complete, the spacecraft will remain on a stable orbit, traveling back and forth between the Earth and the Trojan asteroids for perhaps hundreds of thousands of years. And one day, in the distant future, our descendants may be able to retrieve Lucy. There it is, the plaque you can see on the side of the spacecraft. This was before Lucy was packed inside the payload fairing. But this is meant to be a relic for our descendants of the early days of humanity's exploration of the solar system. And when they do, they will see some great messages. We'll see those. We'll talk more about those in just a couple of minutes. We actually we do have it. So this is a representation. It's hidden a little bit behind your computer, Daryl.
Oh, yeah, let me get that down. Thank you.
But this is the actual plaque on the spacecraft is about a tenth of the size of this, so this is blown up. But it's got a diagram on it. This shows the positions of the planets as they are today on the day of the Lucy launch.
That's right, and there are some great quotes. You mentioned some of the great philosophers and thought leaders over time. Down at the bottom left, you can see that one there is from Albert Einstein. The important thing is to never stop questioning. And then in the middle, we've got the Beatles. In fact, every single Beatle is here, including John Lennon. And he says, we'll all shine on like the moon and the stars and the sun. And then up here at the top, actually right here on the far right, we've got Amanda Gorman, who just came to recent fame at the presidential inauguration. And she actually wrote this poem specifically for Lucy. And there's a great quote in here. She says, hope implores us, may the ancient study and the uncompromising core of us to keep rising for an earth more than worth fighting for. Great words from a young poet.
Yeah, she's an amazing poet. Just blows me away. We are going to now get a look at some more of the messages that we intend to leave behind for our descendants. Take a look.
this is what I want to say to people, to beings, to consciousness who are so far away, I can't even imagine them.
To represent our culture accurately, we should include hopelessness, risk-taking, the role of fortune, good or bad.
To understand each desire has an edge, to know that we are responsible for the lives we change. No faith comes without cost, no one believes without dying. There are no curses, only mirrors held up to the souls of gods and mortals.
Remember, you are all people, and all people are you. Remember, you are this universe is you.
I would just like to say that this wonderful emissary to the Trojan Asteroids is itself a message. Lucy speaks for all that is best about human ingenuity, curiosity, and endeavor.
Do you still have birds that wake you up in the morning with their singing, and lovers who gaze at the stars, trying to read in them the fate of their love? If you do, we'll recognize one another.
And receive those words inscribed on a plaque from all of us, for all of us, filled with those aspirations and that inspiration and that imagination that we need so much right now.
A little noisy, but I'm so excited. Lucy is going back in the sky with diamonds. Johnny will love that. Anyway, if you meet anyone up there, Lucy, give them peace and love from me.
All right, we've got that audio issue taken care of, so we're going to go over now to NASA Edge's Blair Allen, standing by with Bob Cabana. Blair?
Thanks so much, Marie. Yeah, sorry about the technical difficulties. You know, the launch was so impressive, even our gear was affected. But Bob, it's really impressive to see this launch this morning. Tell us, how is it from your perspective?
Well, first off, from my perspective, I got my very own NASA Edge microphone. I'm just elated. Now, Blair, you know, anytime you see a rocket ship leave planet Earth, it is an experience. It's a feast for the senses, sight, sound, and feel. It's emotional. And having Lucy on board, I mean, this is the coolest darn mission, going to the Trojan Asteroids. Looking back at the beginning of our universe 5 billion years ago, absolutely amazing.
And that's kind of what's impressive. I mean, we're talking about this important science mission, but here at Kennedy, we've had 24 launches so far. What's going on?
Well, I tell you, first off, I could not be more proud of our NASA team, our contractor civil service team that has persevered through this pandemic, not missing a beat, you know, making all our missions. I mean, we've launched humans to the International Space Station for the first time since the end of the shuttle program during it. We've launched Perseverance to Mars. You know, we're getting ready to launch James Webb here in December. That's going to be amazing. And getting Lucy off on time. You know, if we didn't get off in this launch window, we're talking another year before we launch.
Yeah, and that is impressive to see how things came together so perfectly. But tell us a little bit about what's coming down the pike. We've seen a lot of things happen here at Kennedy and lots of things to look forward to.
Well, absolutely. You know, I mean, first off, from a science mission point of view, of course, next month we're going out to the West Coast for DART. Then we're coming back here in December for IXBI. In December, down in French Guiana, we're launching James Webb. What an amazing telescope that's going to be. A 21-foot mirror, you know, and then a solar shield, a sun shield the size of a tennis court. You know, they talk about the 9 minutes of terror landing on Mars. Right. We're talking 4 weeks of nail biting as that thing unfolds. But to look back 13.5 billion years, almost to the beginning of our universe, you know, 350 million years from the beginning, it's going to be amazing. And then over in the vehicle assembly building over there in High Bay 3, stacked up, is that awesome Space Launch System, that Boeing core stage with the Northrop Grumman solids and those 4 Aerojet Rocketdyne RS-25s. Yeah. The Orion spacecraft rolls over here on the 19th, stacked down on top. It's going out to the pad for a wet dress rehearsal, and then we're going to launch it to the moon. We're going to do that first test flight without crew in preparation for going back to the moon in a sustainable way so that we can go on to Mars. just so much going on.
I love it. Thank you so much for being on the show. From Center Director now to NASA Administrator, back to you, Marie. Great things here at NASA.
All right, thank you, Blair. One of the asteroids Lucy will visit, Eurybates, has already given researchers a recent surprise revealed by the Hubble Space Telescope. Take a look.
On January 9th, 2020, NASA's Lucy mission team revealed that the spacecraft would be visiting not 7 asteroids as planned, but 8. As it turns out, Eurybates, one of the Trojan asteroids along Lucy's path, has a small satellite or moonlet orbiting it. Finding these tiny new worlds before Lucy is launched in 2021 means that the team can investigate their orbits and plan for more detailed follow-up observations during flybys. Dr. Keith Knoll and other Lucy science team members have been using the Hubble Space Telescope to search for satellites and rings around Lucy's targets. This can be challenging, since the raw images are often filled with bumps, blobs, and diffraction spikes. The Lucy team didn't see any evidence of a new satellite until November 2019. After experimenting with the brightness and contrast on the Hubble images, Dr. Knoll saw a peculiar faint spot near the much brighter Eurybates. Dr. Mike Brown, another team member, noticed the spot showed up in a slightly different position on another set of Hubble images taken 2 days later. This change suggested that the spot was an orbiting satellite. The team went back to Hubble and got 3 more chances to make observations of the possible new satellite. On the first 2 tries, the little moonlet was nowhere to be found. But on the 3rd observation, on January 3rd, 2020, they found the possible new satellite again. It was clearly visible next to Eurybates, which was over 6,000 times brighter. This huge difference in brightness suggests that the satellite is less than 1 kilometer in diameter, very small compared to Eurybates at 64 kilometers. With a few more Hubble observations, the team pinned down the new satellite's orbit, and they proposed a name. The International Astronomical Union approved, and from now on the little satellite will be known as Quetta, after Enriqueta Basilio, the first woman to light the Olympic cauldron. Evidence indicates that the Trojan asteroid Eurybates is the largest fragment from a massive asteroid collision that happened billions of years ago. It is possible that the new satellite Quetta is a remnant of that catastrophic event. Whether with Hubble or with the Lucy spacecraft's flyby, each observation enriches our understanding about the Trojan asteroid's formation and Eurybates' relationship with its newly discovered companion. The discovery of this new moonlet around the Trojan asteroid Eurybates is just a preview of the incredible scientific knowledge that will be captured by the Lucy mission as it explores this area of our solar system.
All right, our next guest is one of the great minds behind the mighty Atlas V, which just had another spectacular launch here. He's standing by with Franklin Fitzgerald from NASA Edge over at the ASOC. Franklin?
Yeah, thanks, Marie. I'm here with Scott Messer, ULA Program Manager. Scott, how did the launch go from ULA's perspective?
Well, it was near perfect so far. We never claim success until we separate and get the spacecraft where it wants to be, but so far the first stage was great. The countdown was very quiet, and it's a beautiful launch so far.
Great to hear. This is a mission unlike any other before it. Can you tell us exactly how unique the trajectory was for the Atlas V on this mission?
Yeah, so certainly the trajectory for the spacecraft is very unique. Probably never been done before. But from an Atlas standpoint, we've launched many planetary missions over the years, and we just kind of did our standard thing in order to get the spacecraft ready to go.
You know, getting ready for this mission through COVID was a challenge for, I know, many people. Were there any challenges that you had to overcome? Is there any kind of anecdote that you can tell about this mission?
Yeah, so the team, it's been a very aggressive week, a couple of weeks with us. You know, we launched Landsat 9 just a few weeks ago, turned around the end of the week. So we launched on Monday, and we turned around and had the wet dress rehearsal here for Lucy on Friday, and then turned around and did our Vulcan PTT test here. So it's been really a very exciting week for the team here, and the team has worked really hard through all the COVID stuff, through all of the activities, in order to maintain the launch date. And here we are right at the beginning of the window, and a beautiful launch so far.
Absolutely. Well, Scott, we wish you the best of luck over the next 12 years, and thanks for joining us here on the show today. Marie, Daryl, back to you to learn more about science.
All right, Scott and Franklin, thank you very much. As you look at the bottom of your screen, I want to remind you we have a progress bar, which is tracking where we're going. You can see that we had the main engine cut off. We're awaiting that second burn of the Centaur, and of course, we'll have all of that for you. But we have about an hour to go before signal acquisition from Lucy. Only then will the team be able to breathe a sigh of relief. So let's hear from some of the scientists about their passion for Lucy in their own words.
Hi, my name is Danya Douglas Bradshaw, and I'm the project manager for the Lucy project, which will be the first mission to the Trojan Asteroids. Building a spacecraft is quite exciting. I worked many decades as a mechanical engineer, really focused on thermal and heat transfer. And so when you work in that capacity, you are supporting the development of spacecraft as well as instruments.
Hi, my name is Dr. Carly Howitt, and I'm the instrument scientist of the MVIC camera on Lucy. I love working on Lucy for so many reasons, but one of them is being able to explore the universe from the comfort of my own office. So I don't have to don diving gear or, go into these dangerous or hard situations. I get to enjoy the data as it comes back from the comfort of my office and explore the universe that way.
My name is Corey Preikel, and I am the mechanical operations lead for the interplanetary spacecraft Lucy. My job is to plan and lead major mechanical operations such as spacecraft transportations, spacecraft crane lifts, or testing of major spacecraft components and ensure they go off without a hitch.
My name is Mike Sakarik. I'm the Deputy Project System Engineer for Lucy. The thing I like the most about Project System Engineering is that you get to touch all aspects of the mission, from the spacecraft, payload, launch vehicle, ground systems, flight dynamics. Project System Engineers have oversight of all of those different aspects of the mission.
I'm Tiffany Kapler. I am a public outreach specialist with the Lucy mission. And one of the things that I love about my job is that it gives me an opportunity to use my creativity and share my enthusiasm for science with others while I get them excited about space exploration.
Hi, I'm Rick Berry, and I am the configuration management lead for the Lucy mission at Goddard Space Flight Center. We're building spacecraft, we're building payloads and instruments at Goddard. We coordinate with our team members to ensure that the configuration management is correct by managing the changes and the requirements.
Hello, my name is Elizabeth McCall, and I'm the project support specialist for the Lucy project. One of the more memorable experiences I've had was just in July of this year. I was able to fly with the spacecraft from Colorado to Florida on a C-17.
My name is Vince Elliott, and I'm the Lucy Deputy Project Manager over Resources. I lead a team of 12, and they are exceptional at what they do. It also means I get to work with some of the brightest engineers and scientists the world has ever known, doing something that I love.
Hi, my name is James Traley, and I'm a producer and animator at NASA Goddard Space Flight Center. And I created the video series you're currently watching right now. I'm so excited to see Lucy launch, and I can't wait to share the complex and exciting discoveries that we make out there at the Trojans to you, the public, through film and animation. Go NASA, go Lucy.
This Lucy mission is dedicated to a number of team members at NASA and United Launch Alliance, some of them no longer with us today. There are 3 dedications placed on the side of the Atlas V rocket. The first says Lucy Strong, recognizing the team's hard work throughout the COVID-19 pandemic. There it is. We got a shot of it before liftoff. And the second is a memorial to ULA team members Mark Kazabowski and William Billy Joyner. Mark was an accomplished engineer and respected mentor. During his 30-year career, he focused on launch vehicle structures and integration. He led the structural design of the Atlas II, 2AS, and 3 development programs. Mark was also a family man, reminding his team always to take care of themselves and their families. Billy spent much of his 35-year career at Lockheed Martin and ULA. He was an accomplished technician who supported critical payload processing for the Department of Defense and NASA. Billy was known for his diligence and dependability, contributing to the successful launch of many historic missions. He was a great friend and teammate to many.
And finally, a dedication in memory of Craig M. Whitaker. His 40-year career began as a student with the Navy. You can see his name there, also on the rocket. That led him to NASA, where he was a founding member of NASA's Launch Services Program in 1998. Craig was instrumental in developing and managing the program's launch service contracts over many years. The final highlight of Craig's career was the award of the Atlas V rocket for the Lucy mission. Craig was a devoted family man, a respected leader, and a humble public servant. And we are here with his son, Craig Whitaker's son, Jared Whitaker, vehicle systems engineer, who also works, just like his father did, for NASA's Launch Services Program. Jared, great to have you here.
I appreciate it. Glad to be here.
How was the launch? How was the experience being up there and watching this rocket, which had been dedicated to your father?
It was really great. I mean, I usually work on the missions and things, and so sitting on console, so it was really great to be able to see it from this vantage point out here at OSB2. Fantastic view from up there, and night launches are always spectacular, and so just really enjoyed it.
What did LSP mean to your father, the Launch Services Program, and then you following in his footsteps?
Yeah, so like LSP, I think he really embodied a lot of the things that LSP stands for, like a good family man, as we said, really dedicated to the work, dedicated to his family, and always curious, always learning new about science missions and things like that. Really meant a lot to him. So I think he definitely enjoyed his 20+ years with LSP and all his time with NASA for sure.
And Jared, we know your dad was one of the founding members of LSP from its earliest days in the 90s, and now you work for the program yourself. I got to ask, did his influence kind of steer you in that direction?
Oh yeah, I would say absolutely. In 1998, I was only 7 years old, and so every afternoon, pick me up from school or whatnot, go home, and over dinner we have conversations about what the last science mission was, what was coming up with LSP, and so he always encouraged me to do whatever I wanted, but I definitely enjoyed going into engineering. And I ended up coming to LSP. I think in my heart I always knew I was gonna end up with LSP, and I'm very glad I did. And so enjoyed the couple of years we got to work together and share more from the business side from him and more from the engineering side from me. It was a nice give and take. So really enjoyed our time for sure.
Yeah, and glad you got to actually enjoy it as a spectator for a change instead of working.
It was very relaxing. It was nice.
Yeah, great. And
there was some overlap between you and your father at LSP?
Yeah, so I finished my master's in mechanical engineering in 2015, and so we worked together almost 5 years. So it was really nice. Like on some afternoons, like later in the week, he'd come by. We're not morning people, so we'd come by in the afternoon and chit chat about how things were going and what our plans for the weekend were. So it was nice to just pass by him and kind of talk a little bit of work, a little bit of personal stuff at the end of the day, and it was really enjoyable to be able to be with him.
That's awesome.
Yeah.
As a non-morning person myself, I used to be. I appreciate you getting up early with us.
It was well worth it. Well worth it.
Thank you so much, Jared.
Thank you all. Thank you.
All right. Thank you for being here. All right. Learning what an asteroid is made of without coming into contact with it takes the right scientific instruments. We'll talk about that in a moment. But first, let's check in with Megan Cruz on top of OSB2 with another program scientist. Megan.
Hey there, Daryl. Yeah, now I have Tom Statler. Tom, what did you think of the launch today?
Oh, it was absolutely beautiful.
Absolutely.
I just couldn't have hoped for a more spectacular launch.
Yeah, and you're the program scientist on this mission. Can you talk to us about what that role entails?
Sure. I mean, all of our missions have program scientists at headquarters. We're the main science advocate for the mission, and we also work with the mission teams kind of as coaches to make sure that the science ambitions that they have for the mission fit with NASA processes.
Gotcha. And we saw Lucy lift off about 30 minutes ago. Can you talk to us about how her three main instruments are going to work together to study the Trojans?
Sure. So Lucy has three main instruments. There's the LORRI, which is a high-resolution black and white camera, LORALF, that is a spectroscopic camera, and LATESS, that is a thermal imager, like a no-touch thermometer. And so we'll be able to get detailed images of the landforms, the craters, cliffs, landslides, anything else that's been going on the surfaces. LORALF will be able to tell us about composition, so we'll get an indication of the mineralogy, the chemical composition, and Lattès will tell us from the temperature readings what's the texture of the surface. Is it rocky? Is it sandy? Is it gravelly? They all work together to tell us what's going on these asteroids.
Wow, without even landing on them, that's amazing. And we know that Lucy was named after the Lucy fossil. The Lucy fossil was named after the Beatles song, Lucy in the Sky with Diamonds. And actually, Lucy actually has a diamond on board. Can you talk to us about that?
It does. So the Lattès instrument, that touchless thermometer, is an interferometer, and people who are into instrumentation know what that means. But in an interferometer, you need to divide the incoming light into two paths, and so you need a device, an optical device called a beam splitter. And one of the best ways to make a beam splitter is to make it out of synthetic diamond. So there is a synthetic diamond, not a natural diamond. It's a pretty big one. I understand it's about 20 carats, which would make a big piece of jewelry.
Diamond ring,
but
yeah.
it's an industrial piece of synthetic diamond that's really essential for getting these temperature readings on the surfaces of the Trojan asteroids.
Awesome. And you're also the program scientist for DART. That's scheduled to launch next month. Can you tell us about that experiment?
I can. Well, DART, like Lucy, is going to an asteroid, and that's where the similarity ends. Because DART, Lucy, of course, is going to the Trojan asteroids in the outer solar system, and DART is going to a near-Earth asteroid, not so much with the intent of studying it, but to demonstrate that we have the technological ability to be able to deflect an asteroid if we're ever in a situation where there's an asteroid on collision course with Earth. There is not one now. No known asteroid is on a collision course with Earth, and the asteroid that we're going to collide with deliberately with the DART spacecraft is not a danger to Earth, and there's nothing that we can do to make it a danger to the Earth. But we're going to test our ability to target an asteroid, to execute a kinetic impact, that is, run a spacecraft into it, and then we're going to test the asteroid's response to that impact. How much do we move it by, and how effective that will be to protect Earth in the future.
Sounds like a movie. Strange, huh?
No, maybe not with as dramatic a script as some of the past movies, but it'll be very exciting when we execute the kinetic impact and then get the data from ground-based telescopes afterwards that tells us what we actually accomplished.
Great, Tom. Thank you so much. I appreciate you being here.
Marie,
back to you.
All right, thank you, Megan. If you're just joining us, we had a spectacular launch this morning in Florida. NASA's Lucy launched into the sky with a diamond, a pretty big one, it sounds like,
apparently.
About 36 minutes ago. And the spacecraft lifted off on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral Space Force Station. That was at 5:34 a.m. Eastern Time. And in just a little bit, we expect to hear confirmation of spacecraft separation.
And there's a replay of the launch from this morning. A beautiful shot there as you see the Atlas V launching away from Space Launch Complex 41 here at the Cape Canaveral Space Force Station. It was a beautiful launch, and every launch is always a little different, right? We had some clouds up high, and it went behind them and then popped back out.
Yeah.
I love that.
I love when it illuminates the clouds, because you don't, I mean, it's pitch dark behind us now, and so you don't even know they're there, and the rocket just lights up the entire sky, and it's stunning.
It's like a sunrise. Wonderful. All right, the Lucy spacecraft, named after the early human fossil and the famous Beatles song, is just beginning a 12-year mission to uncover the mysteries of our outer solar system. Lucy shows us more.
Lucy's long journey to space begins today, but her story actually started years ago. It took a team of scientists and engineers many years to plan where Lucy would go and what she would have to do. Then, Lucy's engineers had to build her out of individual parts and put her together like a puzzle. Lucy had to go through tough physical tests to prove she was mission ready. How are you holding up, Lucy? These are the vibration and acoustic tests to make sure that Lucy won't lose any screws during the shaky launch on a rocket. Lucy wasn't quite ready just yet. The engineers still had to be sure that she was prepared for the harsh environment of space. They chilled Lucy to freezing temperatures, then warmed her up to scalding hot temperatures in the thermal vacuum test. Sure, those tests weren't easy, but they prepared Lucy for the long adventure ahead.
1, 0, have ignition. And liftoff.
We're glad you can join Lucy on her adventure to explore the Trojan asteroids. Now, let's get the journey started.
I'm really starting to love that cartoon Lucy.
Yeah.
She's great.
Really cute.
Thank you, Lucy. Let's send it over now to Megan. She is with the paleoanthropologist who discovered the Lucy fossil in 1974. Megan.
Yeah, Daryl, what an honor to have Donald Johansen here with me today. Good morning to you.
Good morning to you.
You know, you have to take me back to that day when you discovered Lucy in Ethiopia back in 1974. Tell me how you found her.
Well, it's amazing. It'll be 50 years since that discovery, 2 years from now. I was a young anthropologist. I was searching in the extreme northeast of Ethiopia looking for remains of our human ancestors. I glanced over my shoulder one day. I saw a little piece of bone, recognized it as belonging to a human skeleton, and it led to Lucy. And Lucy has become the benchmark by which all discoveries are judged.
That's amazing, just to see over the shoulder. Like, how did you pick this small piece of bone out from all around you?
Well, you know, when you're out there, you train your eye. And you know how we always say you find something in the last place you look? Well, that's sort of like what happened.
Oh, my gosh.
I carry these images in my mind of bones and teeth and so on. And when I saw that piece of elbow, I knew it couldn't be from a baboon, it couldn't be from an antelope. And from all the work I had done in graduate school, I knew that it had to come from a human ancestor.
And why did you name her after the Beatles song?
Well, I thought it was a female because of the very small size of the bones. And we thought, well, is this a child? No, the third molars were erupted, the wisdom teeth, as we call them today. And that night in camp, in the middle of nowhere, when we were celebrating her discovery, we were listening to a Beatles tape, Sgt. Pepper's Lonely Hearts Club Band, and the song Lucy in the Sky with Diamonds was playing, and someone said, why don't you just call her Lucy? And that was it. You could not go back and call her anything else.
No,
that
I love
became
that
her
name.
Yeah.
And now you just told me that this was your first launch and it gave you goosebumps. That's so wonderful. I mean, how was it to know that there's a spacecraft on there that's named after the fossil you discovered?
Well, I will never look at Jupiter the same. Jupiter was always interesting to me as a kid. I had my little telescope. I watched the moons go around Jupiter. And to be out here this morning was absolutely mind-expanding. And it was such a positive experience. You know, the world is going through some tribulations. Something as positive as this is, people should look at and see what the creativity of the human mind can do.
Yeah, Don,
and there it
thank
is.
you.
She's on her way.
Yeah, I'm so glad you were here for this.
And she will tell us so much.
Yes,
and
awesome.
I just had goosebumps.
Yeah, perfect. Thank you so much for being here. I appreciate it. Why don't we send it back over to Joshua and Mick for another update on Lucy.
Hey, thanks so much, Megan. Unfortunately, we didn't quite fly over Ethiopia. We did fly over part of southern Africa on our way there, and we're in the middle now of the second burn of the Centaur. Mick, talk to us about what the second burn is.
So main engine start did occur just a few minutes ago, and this will get Centaur and Lucy into its transfer orbit, leaving the park orbit around Earth, heading into that orbit, to get Lucy on her way to the Trojan asteroids. So very important burn. This will last about 6 minutes and to get her the velocity and everything she needs to go to get on her way to the Trojan asteroids.
There you go. So just under about 4 minutes left in this burn. So going back today, we did kick off at 5:34 on the button and got a report.
Storage pressures during the burn.
From
storage bottle pressures look good.
From the ULA commentator Rob Kesselman, ULA always expecting excellence, but he reported that the booster performed better than expected. I'm not sure what's better than excellent, but they got it today.
Yeah, it just means we had some great performance from the first stage booster in the RD-180, putting Centaur into the proper orbit and that injection that they needed for getting Lucy on her way. And now that we're into main engine start 2, that just means we have a more precise trajectory, and everything's looking good. The spacecraft customer and ULA and Launch Services Provider program are very happy at this point.
Yeah, so Lucy, after this burn is completed, we'll then wait a few more minutes before we get into separation from the Centaur. And at that point, Lucy will be set up for her first orbit, her first major orbit of Earth, which will be just under 1 year to complete and then have the first Earth gravity assist flyby, where Lucy will get close enough to Earth where she'll literally just be, it's like a slingshot effect, where she will just pick up speed flying past Earth to start getting out towards where the asteroid belt and the Trojan asteroids are.
Yeah, first of three gravity assist.
That's right.
So it'll be a big move for her.
That's right. And so again, thinking about the complexity of this, it's a little bit shocking to think about. The first asteroid won't be explored, won't be passed by for another 4 years. And then beyond that, there's another gravity assist later on down the road after a few Trojan asteroids being explored.
Yeah, 12-year mission. Very excited about this. We just started this morning, right? And the team did a great job, developing this trajectory and making sure that we could get out to those Lagrange points that needed where those asteroids are.
Is it Lagrange or Lagrange?
It's Lagrange.
I think depending upon what part of America or the part of the world you're from, it could be a different pronunciation there.
Daryl reminds me all the time it's Lagrange, but if you're from the south, it's probably something else. I don't know. But Lagrange points where the Trojan asteroids are in L4 and L5, and that's a very important. I mean, this team did an excellent job in this trajectory design, and Centaur is on target to deliver Lucy on that path.
Yeah, so the Lagrange points, a little explanation there. So for every pair of planetary bodies that are interacting, that are kind of engaged, there are 5 Lagrange points, and those 5 Lagrange points are in very consistent places. And what that means is that a lot of people have this notion that if you're in low Earth orbit, the space station, for instance, that you are in zero gravity. This is actually a misconception. You're in what we call microgravity. Yes. And so as you're in orbit, you're essentially falling around the Earth. And so gravity is still about 98% of what it is right here now. And so when you're at a Lagrange point, there's actually a balance of gravitational forces where you're able to essentially sit there in what really is a zero gravity. That's probably a more appropriate place to describe zero gravity. Again, you mentioned Lagrange points 4 and 5. That's where these 2 groups of Trojan asteroids hang out. And these are actually nowhere near Jupiter. So they're Jupiter's. Sorry, we're getting calls here. Good performance here on the Centaur still, as they're about to wrap up this second burn, again, preparing for spacecraft separation.
From MECO 2. And we have MECO 2.
That's a good sign right there. Main engine cut off 2. That means Centaur has done its job, performed, and
100%
will be
RCS system.
coasting for just a few minutes as we get ready for spacecraft separation, and Centaur makes sure she's pointing in the right direction.
That's right. And so just finishing that thought, the Lagrange points 4 and 5 are roughly equidistant from the Sun and Jupiter, making isosceles or equilateral triangles. If you're ready for your math at 6 a.m. Or whatever time it is right now, we're watching our mission clock here, and so essentially they are the same distance from Jupiter as Jupiter is from the Sun, which is roughly 465 million miles. So these points are very far from Jupiter, very far from the Sun, but pretty exciting. And Mick, LSP, no stranger to exploring the solar system, no stranger to mission success with science missions.
Yeah, we are very happy to be working with United Launch Alliance, our commercial partner today, with this Atlas 5401. This mission started 7 years ago for some of these folks, some longer. And as the Atlas 5401 was selected for this mission, LSP took all those requirements from our spacecraft customer, and we looked at those and we decided what needed to be done, and we selected the Atlas V for this mission. Our team of engineers, scientists, and analysts worked very closely with the spacecraft customer and United Launch Alliance, and as a result, we had a successful liftoff at 5:34 a.m. today, at the very beginning of our window and the beginning of our science period. So very happy so far. Still waiting for that spacecraft separation and making sure the spacecraft's healthy, but so far everything has been going just as we had predicted.
Yeah, very good. A reminder coming up ahead, we have spacecraft separation. As you say there, a countdown to when we're expecting to see that happen. What you're seeing on screen is a graphical representation based on real telemetry data. So we are confident this is what's happening in space right now. But that's not actually a live video.
Now stabilized at the coast attitude.
And so again, there you see on your time, we're expecting that spacecraft separation in about 9 minutes from now. So After that, we will have a brief period where we'll wait to start solar array deploy. Then we'll have that takes about 20 minutes to deploy the solar arrays, big beautiful solar arrays, and then we will, once those are up and powered, we would expect a couple minutes later to be able to get that acquisition of signal.
That's a very scary time for the spacecraft team. They'll be waiting for that for sure.
Yeah, absolutely. All right, I think we are ready now to send you upstairs to NASA Edge's Franklin with the Lucy program manager.
Thanks, guys. Yes, I'm here with Donya Douglas Bradshaw, who is the Lucy project manager. Donya, how you doing today?
I'm doing awesome.
Great. How do you prepare for a mission like Lucy when nothing quite like this has been done before?
Well, it certainly takes a team of engineers, scientists, everyone. Dr. Hal Levinson, who is the Lucy PI, has a vision, and it takes a team of hundreds to bring that vision to fruition.
How long have you been working on this project?
So I joined Lucy about 3 years ago. Joined the team as the deputy project manager, and then about 2 years ago became the project manager.
Now, do you have any exciting stories to tell about this mission? Because you all had to work through COVID to get this thing up and running.
Yeah, COVID happened in March 2020 unexpectedly, and there was a lot of uncertainty around that. And but this team and this spacecraft development led by Lockheed Martin quickly, rapidly, without missing a beat, put together a plan to enable us to re-engineer the integration and test program.
I know within the last 2 years, the components for the spacecraft were, compiled, but it wasn't even put together. How did you get that all up and running basically in a little over a year?
Yeah. So, I mean, the plan, you're right. When the pandemic happened, we were about 5 or 6 months away from the start of our spacecraft integration and test program. And so there was a lot of uncertainty, but the entire team came together and really devised a way to keep people safe, do social distancing, adding the capability for folks to monitor the integration and testing remotely, using collaboration tools, online tools, just different techniques that were available to us. And so we were able to do that. Certainly there were some inefficiencies, but we were able to compress our schedule so that we could stick to this launch date.
Great. Donya, thanks for joining us this morning, and continued success.
Thank you very much.
All right, Daryl, back to you.
All right, Franklin and Donya, thank you so much. Earlier you heard a little bit about the Lagrange points. I got a primer from Mick and Joshua, and so now let's revisit that. Lagrange points are two gravitationally protected zones that are around the orbit of Jupiter. Here's Principal Investigator Hal Levinson and Lucy to help explain.
The Trojan asteroids are found in Lagrange points, which are these special places that lead or follow a planet in its orbit by 60 degrees. And it's sort of where the gravitational force of the planet and the gravitational force of the sun all cancel out. So if you put an object there, it will stay there for a long period of time, basically forever. So when we see objects there, these are objects that we know were in place a very long time ago. So if you just take a random asteroid and just put it in the outer solar system, the gravitational force of the 4 giant planets will just clear them out in a very short period of time. So they'll basically be gone. So the only places, it turns out, in the outer solar system where you can find stable regions are these Lagrange points. Lucy in particular is going to go after the Jupiter Trojans. We're trying to see a type of object that represents and constrains the formation of the outer planets. And you need to go to these Lagrange points in order to see that kind of object. One of the really groovy aspects of our mission is its trajectory, because we're visiting a record number of objects like these Trojans. And we do that with this very complicated dance, particularly in the beginning, where we are using the Earth actually as a gravitational slingshot. So Lucy will start off in an orbit very similar to the Earth, and then gravitational encounters with the Earth will actually pump it up so it gets out to the Lagrange points near Jupiter's orbit. So if you're going to understand how planets like the Earth formed, you have to understand how the bigger planets, which sort of dominated the whole process, came to be. And that's what Lucy is going to do.
Well, that was Hal on tape. Let's join Hal live now, who is with Blair from NASA Edge. Guys, take it away.
Thanks so much, Daryl. Hal, obviously an incredible launch. You've been very involved and very important to the Lucy mission, but tell us about the experience of being on console and seeing the launch this morning.
It was one of the most exciting experiences of my life. It was truly awesome in the old-fashioned meaning of that word, right?
Well, I mean, you've carried this mission for so long, so seeing this happen, what a great moment, not just for you, but for the whole team.
Well, it's been a team effort, there's no doubt. Danya talked a lot about how it took a really village to build this spacecraft, right? And under some very difficult conditions. So, sorry.
No, it's an emotional moment. I mean, this is a big deal.
It is,
obviously.
and it's been the last 24 hours has just been a roller coaster of excitement and build up, and everything was a success.
Tell us a little bit about your history with Lucy. How did it all start for you?
Oh, we started this project back in 2014. I think the first email that I have that had the word Lucy in the subject was in March of that year. And we've been working and competing against other missions since then. It's been a haul. And, you know, the amazing thing about doing something like this is that it was all paper and PowerPoint until about a year and a half ago. And then the folks at Lockheed took these concepts and built a spacecraft.
And you know what's amazing too is you had a very interesting window. You really needed to launch today, or you'd have to wait a long time before you could try again.
Well, we have a spectacular trajectory. I think you've been talking about that all day. We're going past an amazing collection of objects. And we have one chance really to do this. The planets are literally aligning in order to make this trajectory happen. So we either launch today, or a year from now we do an EGA, an Earth Gravity Assist. We could launch directly at that time too. So we have two chances, and luckily we got it off and it's going.
And you were able to you were on console, but you came up and actually saw the launch personally.
I was not going to miss that, right? It's like witnessing a birth of a child, right? You just really had to see it.
And now you watch the child being raised.
That's right. Right. I mean, the analogy of pregnancy and then a birth and then raising a child is really good for what we've been going through here.
Great metaphor. Thanks so much, Hal. We really are excited for you and the Lucy mission. Back to you guys.
Go Lucy.
Hey, yeah, go Lucy indeed. We are standing by.
For tumble check.
In just 30 seconds, we are continuing to hear those calls that we are on track.
Back on at 20%.
So obviously a big moment, especially for the ULA team. This would be the end of their task.
Centaur is now spinning up in anticipation of spacecraft separation. 15 seconds.
Huge moment here for all the teams, actually. Successful launch.
5
This
seconds.
is what it's all about.
Spacecraft set. We have indication of successful separation of the Lucy spacecraft.
So we're hearing some clapping here in the MDC here at the ASOC, Joshua, and that is a huge moment for all of the teams. We still have quite a bit to go. Solar array deployment, we talked about those earlier. Those big, huge solar arrays that are needed, and the spacecraft team will be awaiting to get confirmation that that has started, and then there'll be 22 minutes, what they refer to as 22 minutes of terror, waiting for those solar arrays to deploy. And of course, they have to get acquisition of signal to verify all that slightly after that. So the next few minutes as we get through this is going to be spacecraft team will be kind of sitting around waiting to see what happens and making sure Lucy is healthy and doing well. But spacecraft separation, huge milestone for the teams working the launch vehicle today.
Yeah, I mean, Mick, even here, I got some goosebumps. Like, it's chills in that moment of just like, you can feel the energy of the people around you, just like so excited. And obviously, that applause is very genuine. This is a serious moment, but it's also like a really joyous moment. And you'll see the ULA team, obviously, this is the end of their major task for today. But NASA Launch Manager and the NASA LSP team, they will continue to stay with this because for you guys, getting the spacecraft healthy is the mission. It's not just the launch. It's making sure that they get on their way successfully.
That's correct. We want to deliver mission success, as Dr. Z talked about earlier in the show, right? One of the things we want here at NASA is mission success, and that's all the way through making sure our spacecraft customer knows what's going on with their spacecraft and everything is well. So we'll be standing around waiting for solar array deployment. That'll begin here about 4 minutes after the, about an hour and 4 minutes after launch, about 6 minutes from now. And we'll go from there.
Yeah, so again, it's going to be a process that will start at roughly L plus 104.30, and then from there, we will wait about 22 minutes is the expected time to complete solar array deploy. Those 24-foot diameter, beautiful solar arrays, taking up most of the size, the physical length of the spacecraft, and then we won't actually get confirmation of that for a couple more minutes because those are designed to power the spacecraft all the way through its mission. And so there will be a couple minutes where the communication is being established between the spacecraft and the ground. Not a simple process. We'll talk that in a few more minutes. Once we get closer to that acquisition of signal moment milestone, we'll kind of talk through how we're doing interaction. I think, and I know there's a chance we could potentially pick up the actual live video. It wouldn't be live at the moment, the actual video from spacecraft separation. If we do catch that, we'll bring you that.
ULA recorded that on board, and as they get closer to their download point, they'll be able to download that. I don't know if we'll get that right away or not, but it was recorded, and eventually that will be shared with the spacecraft customer. Another unique thing, we were talking about those solar arrays, why it's so important, is I heard earlier today that, those things generate about 5,000 watts. That's all that the spacecraft uses. Man, that's not even enough to run a microwave here, right? So that just shows you how efficient the spacecraft is.
Yeah, very good. Getting a few views there from around the country. We had one from ULA headquarters in Colorado, that there in Hangar AE with some spacecraft folks. But for now, Daryl, we're going to send it back to you. I'm sorry, to Marie.
All right, thank you, Joshua. Time to catch back up with our Lucy cartoon character. And in this next episode, Lucy wants to show you where she's going and why she's studying the Trojan asteroids.
You might be wondering, where is Lucy off to? Yes, the Trojan asteroids. These are a population of asteroids in orbit around the Sun, about as far away as Jupiter. It may seem far away to you, but our Lucy spacecraft is a capable explorer and ready to make the trek to her targets. Lucy is aiming to visit asteroids in both of these Trojan swarms on her 12-year mission. The pull of gravity from the Sun balances the pull from Jupiter to keep the Trojan asteroids in these two groups. Due to the gravitational balancing act, these asteroids have been in these orbits for billions of years. It's still quite the challenge to explore these targets. However, our intrepid explorer is ready for her mission. Aren't you, Lucy? Of course. You'll be the first spacecraft to visit these asteroids. I can't help but wonder, though, why choose these asteroids in particular? I see. The scientific evidence says the Trojan asteroids are leftover material from the formation of the planets. Right. These asteroids hold vital clues to understanding the history of our solar system. It's just like a treasure hunt. What you discover could teach us about the history of the solar system and how the planets, including Earth, came to be the way they are. I won't hold you up any longer. safe travels on your journey. Be sure to write home and tell us all about it.
Welcome back out here to the broadcast area, and now we'd like to introduce you to a special guest, Audrey Martin. She's a graduate student at Northern Arizona University and played a role in today's launch. Audrey, you're a student and you were involved with the Lucy science team. How unique is that?
It's incredibly unique. I feel very, very privileged to have been able to work with the science team and also be here for the launch. It's absolutely amazing.
What specifically did you work on?
I have been working with the science team, so I do surface composition, spectral analysis stuff, and I've been working with the surface composition working group to really understand everything that we can understand now about the surface of Trojan asteroids, so that when we get there, we can learn even more and we can be really prepared for what we're going to see and what we're going to discover.
You've seen the successful launch. We all watched it here. That was pretty cool.
Yeah.
We just saw successful spacecraft separation, but now we're entering that tense moment where Lucy's unfurling those gigantic solar arrays. What's that like for you right now?
I mean, I'm very optimistic. So far, everything that has gotten in the way of Lucy and the success of the mission, everyone has come together in a very collaborative way to overcome that. And so I'm very
like it's destiny, huh?
Yeah, I'm very optimistic, and I think it'll go really well. And it will.
And if other students want to do something similar, how do other students team up with NASA like you did?
Yeah, great question. So there's this program that the Lucy mission has put together with Arizona State University. It's called LaSpace. L''space.
How fitting.
Yeah, it's
perfect.
Super cute. And it's for undergraduate students who are interested in working with NASA and working as a team and working on, designing missions and stuff like that. That is really exciting, and it's new. It's something that I didn't get to experience in undergrad, and I would have absolutely loved it. So if anyone out there is interested in it, you should definitely look up the space program.
All right. Thank you so much, Audrey. Thanks for being here.
Thanks.
All right. Very good. And as you look at the bottom of the screen there, you can keep track as we are watching solar array deploy. You can see the timer is at 20 minutes and counting down. And we, of course, are monitoring the spacecraft team to find out the latest. Now, let's get back to that cartoon Lucy, right?
Yes.
She's kind of a hit.
Yes. And in the next episode, we hear from Lucy's flight navigator, who discusses how the team directs Lucy on its journey to the Trojan asteroids.
So to steer a spacecraft from millions of miles away, we have to first track its trajectory. So we have to determine where in the solar system the spacecraft is, predict where it's heading, and compare that to where we want it to go. So the navigation team ensures Lucy's on the right trajectory by tracking Lucy's position and velocity in the solar system, predicting where it's headed, and adjusting its course so that it aces the flyby. So once Lucy starts approaching one of its asteroid targets, the navigation team utilizes the instruments, the cameras on board, to take pictures of the asteroid and background stars, and that helps us hone in on targeting this close flyby. So commands travel at the speed of light, and over the course of Lucy's trajectory, its position from Earth is varying substantially. When Lucy is near Earth during our Earth gravity assists, it takes mere seconds for the data or commands to be received by the spacecraft and for the spacecraft to send data back to us. But at the farthest extent of Lucy's trajectory and the farthest distance from Earth, it can take up to an hour for our commands to be received traveling at the speed of light. It's not only the data encoded in the signals, but it's the properties of the signals itself. We know what time the spacecraft sent the data, and we know what time it was received on Earth. So we can calculate how long it took the signal to travel at the speed of light, and that gives us information about how far Lucy is from Earth. And then we also can get velocity information because the spacecraft is moving away from the Earth as it's sending those signals, and so there's a change in the frequency of the radio signal, and that gives us information about velocity. So like all NASA missions, Lucy is designed to be robust to anomalies or surprises. But in the event that something unexpected happens, there's either a contingency plan on the shelf or a group of relevant mission experts are brought in to come up with the best solution to solve the problem.
A little less than 6 years from now, Lucy will fly by the first Trojan asteroids in the mission, Eurybates and its small moon, Keta. This next episode of the Lucy cartoon series shows us an illustration.
There it is, Lucy. Your first Trojan asteroids. Eurybates with its small moon, Keta. Earth to Lucy! Remember, you need to take a lot of images of Eurybates and Keta in not a lot of time before you're zooming off to your next target. Make sure you get all those images for us. It's beautiful, isn't it? And we're past. Whew, that was quick, right? Get any good data? That's great to hear. Can't wait to see them. Just send them back to us here at Earth. We have so much to learn from what you've already sent back to us, and you're just getting started out there.
So remember, it will take Lucy 12 years to visit all 8 asteroids on her journey, and the next group of Trojan asteroids Lucy will visit each has its own unique characteristics and lessons to reveal.
There's still 5 more Trojan asteroids to explore on your 12-year journey. Each one has a different story to tell about the history of our solar system. Next up is Polymele, a mere 21 kilometers or 13 miles in diameter. Afterwards, you'll be zooming by Lucas, which rotates at an extremely slow rate, with each day being about 18.5 Earth days long. Afterwards, you'll be on to Orus, which might be rich in organics and carbon. Lastly, you'll be on your way to a twin pair of asteroids, Patroclus and Menetius. These asteroids, relatively unchanged over 4 billion years, will give us a glimpse of our solar system's distant past. With each flyby of a Trojan asteroid, you'll be looking at time capsules from the birth of our solar system over 4 billion years ago. Lucy, what your observations tell us about the composition and properties of the Trojan asteroids could give us clues about how Earth came to be. Absolutely. Carry on your journey, Lucy. And don't forget to call and show us what you find out there. We'll be waiting. Good luck.
Thank you, Lucy. The Trojan asteroids have been called ancient time capsules. So you know what? We've got a challenge for you to create your own time capsule to open when Lucy completes the mission in 12 years. Here's how you can get involved.
March 2nd, 2033. Where will you be? The Lucy spacecraft will be right here. But what about you? Over the next 12 years, NASA's Lucy mission will explore more asteroids than any previous mission, flying by 1 main belt asteroid and 7 Trojan asteroids. These ancient time capsules will allow us to trace the origins of our solar system. We invite you to accompany Lucy on its 12-year journey by creating your own time capsule. Set aside a box of mementos, create a digital file, or simply write a letter to yourself. Get creative. We encourage you to post a photo, drawing, video, or other description on social media using the hashtag LucyTimeCapsule. At each major mission milestone, we'll remind you to revisit and add to your time capsule. Consider, what would you tell your future self In what ways will you grow? How do you want to mark this current moment in your life? Lucy carries her own time capsule into space, a plaque with words of wisdom for our descendants who may one day come across the spacecraft long after its primary mission ends. The messages encourage hope and humility, knowledge and curiosity, appreciation of humanity, and exploration of the cosmos. We hope you'll join us, and Lucy, as we look with anticipation upon the unknown of our future, both as individuals and as humankind.
And remember to use the hashtag LucyTimeCapsule when you are sharing your videos and photos on social media. And we can't wait to see what you come up with and what Marie comes up with. Look at here.
I heard about this project and I got so excited. So I came prepared with my own little time capsule items. I have a picture of my kids.
Aww.
They're both under 6, so they're going to look so much different when Lucy gets done in 12 years. They might not like me as much then either, but
box is pink.
So we got to remember this moment. I've got one of their favorite toys, a unicorn.
Aww.
Some patches from missions this year. The Crew 2 one they launched earlier this year, and the Lucy mission patch, of course.
Good.
A pair of my kids' shoes because I'm sentimental. A mask.
What's this?
Because it's a face mask. I mean,
that's
it
pretty
will remember
appropriate.
the times. And my first plane tickets from my first post-quarantine trip on an airplane. How about you, Daryl? What do you have?
Well, I don't have all that, but you know what? I wore some socks that are my planetary
You wore
socks. You see that? I mean, we don't want to show the audience that.
He's taking off his
I'm going to take off. But this is great because you know why? That's Jupiter on my sock, right?
All right, well.
And so on the other side, what's that, Marie? I don't know. Maybe some asteroids?
It looks like Eurybates, maybe. You know,
Great.
But you know what? I was going to share this with you, but you just took that off your foot so you can get your own time capsule box.
I can't put it in the little girl's shoe?
You can put it in my baby shoe,
Okay,
sure, yeah.
Great.
All right, and we have first light right behind us. You can start to see sunrise hasn't happened yet. This is just beautiful.
This is a beautiful view. This is the Kennedy Turn Basin where we brought in the shuttle main external tank and also brought in the core stage for the Artemis mission, and that's going to be a great one.
Yeah, so much coming up here on the Space Coast. We heard a little earlier from Lucy's project manager. Now here's a recap in her own words about the work it took to get Lucy into the sky.
The Lucy mission is a planetary mission to the Trojan asteroids that are around Jupiter. It's going to survey actually a total of 8 targets, 7 asteroids around Jupiter and 1 asteroid in the main asteroid belt. Once you know where you're going and the type of science that you want to take, one of the things that you start looking at is the spacecraft. What size spacecraft? Where is it going? How much power does it need to carry? Does it need solar arrays? What type of solar arrays? What type of vehicle is going to be used to launch it into space? So that dictates how much mass you can carry. And one of the things I do as a project manager is to assemble a team of scientists and engineers and technicians and business people to design that overall spacecraft to achieve your mission. In designing the spacecraft, you are always thinking about what type of environment is it going to be subjected to. Is it going to orbit around Earth? Is it going into deep space? Is it going to Mars? Is it going close to the sun? And so as engineers, one of the things that you're thinking about very early on is how can you design this system and test this system in order to verify and convince yourself that it's going to survive in space. And as part of that, it goes through a very rigorous test program. And so we call it shaking and baking. And so we actually put it through what we call a thermal vac chamber in which we simulate the space environment. We also put it on what we call a vibe table in which we vibrate it, so we shake it. And one of the important things that you have to do in order to be convinced that it's going to survive is to make sure that the environment in which you're testing it in, the simulated environment, is harsher than what it's going to see in space. So once you subject that spacecraft or that instrument to that environment, then you can have confidence that it's going to last the lifetime that it's been designed for.
All right. Thank you very much, ladies. As you can see at the bottom of your screen, we are counting down to confirmation of solar array deploy and acquisition of signal. Just about 8 minutes to go in that. Now, many of NASA's unique science missions have one thing in common, and that is the Launch Services Program that helps each mission take flight. LSP is the common thread.
Since the dawn of humanity, we have looked to the stars and dreamed of bridging the gap between the Earth and the cosmos. In the 20th century, NASA turned that dream into a reality by launching humanity into a bold era of scientific discovery. As pioneers of space travel, our best and brightest designed and built everything from the ground up, from launch pads to rockets, all of which were government-owned and operated. As NASA's science and robotics evolved, we encouraged a competitive launch market to develop, ushering in a new way to explore and discover through commercial spaceflight. Spacecraft customers from around the world, all with the same desire, reached out to find an expert at NASA for support. Thus, NASA's Launch Services Program was born. Our mission is to centralize NASA's launch services and address state-of-the-art customer needs when placing their spacecraft in orbit around the Earth, the Sun, or destinations deeper into the solar system. The LSP family is made up of a diverse tapestry of government and contractor engineers, analysts, operation experts, and business advisors, all united by a common goal: to get your spacecraft off the ground on time, on budget, and successfully to its final destination, wherever that may be. We match scientific and robotic spacecraft with the appropriate rocket and certify rocket performance and reliability. We support full-service missions, advisory services, and one-of-a-kind contracts. The Launch Services Program is the common thread that bridges the spacecraft organization to the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through launch. Whatever the vision or requirements, our team will be there, guiding our customers every step of the way on their journey through space. We are the common thread that connects the science world to the physical world by putting the necessary instruments in place. The thread that weaves NASA's industry-leading knowledge and support into the fabric of the commercial space market. We unite customers, capabilities, and culture to explore space through unparalleled launch services. NASA's Launch Services Program. We are Earth's bridge to space.
All right, we are now at launch plus 1 hour, 21 minutes, and just under 5 minutes away from what we hope will be acquisition of signal. We're still inside that 22 minutes of terror when we don't know that yet. That's why I say we hope. We'll find out in about 4 minutes now. We will be checking in with the launch team in just a minute, but before we do that, NASA's Launch Services Program has a really busy rest of 2021 planned. Here's a preview of what's ahead.
Since 1998, NASA's Launch Services Program, or LSP, has served as Earth's bridge to space. Based at NASA's Kennedy Space Center in Florida, the program matches scientific and robotic spacecraft with launch vehicles for some of America's most inspiring space missions. Our mission: to successfully place spacecraft in orbit around the Earth, the Sun, and destinations deeper into the solar system. We centralize NASA's launch services while addressing state-of-the-art customer needs. But LSP does more than pair spacecraft with the appropriate rocket. The diverse group of government and contractor engineers, analysts, and advisors certify rocket performance and reliability. The team provides long-term technical expertise and support to spacecraft customers from around the world. The team manages launches from multiple sites depending on customer and mission needs. Cape Canaveral Space Force Station in Florida, Vandenberg Space Force Base in California, Reagan Test Site at Kwajalein Atoll in the Republic of the Marshall Islands, and the Pacific Spaceport Complex in Kodiak, Alaska. Building off of past success, LSP forges ahead to support NASA's future. Lucy will be the first mission to study Jupiter's Trojan asteroids, which may be remnants of the primordial material that formed the outer planets of our solar system. It's then back to the West Coast for Double Asteroid Redirection Test, or DART, NASA's first planetary defense mission. That will be followed by Imaging X-ray Polarimetry Explorer, or IXPE, launching from Kennedy. IXPE will expand our understanding of X-ray production in objects such as neutron stars and black holes. Years of testing, determination, and dedication, working as one. NASA's Launch Services program is Earth's bridge to space.
All right, just about 2.5 minutes until we hopefully finish solar array deploy. 2 minutes after that, we're expecting to get the acquisition of signal as we dawn here at a beautiful shot behind us, Marie, of the sun getting ready to rise here at the Kennedy Space Center, the Kennedy Turn Basin behind us. What a beautiful sight.
Yeah, storybook picture behind us. And as you saw in that video, the next mission for NASA's Launch Services program is the Double Asteroid Redirection Test. We call that DART. That's currently scheduled to lift off November 23rd. I think it's Thanksgiving Eve over on the West Coast, Vandenberg Space Force Base. So we're really excited for that one. And more details you can find on that at nasa.gov/DART.
And so, while we stand by to find out more information about the situation with Lucy, we want to just say, hey, this is a long journey ahead of her, but these moments right here are very critical, especially that confirming of that solar array deploy. So let's toss it over to Joshua and Mick over at the ASOC, who will talk us through it. Guys?
Yeah, thanks, Daryl. Man, what an exciting year ahead. Obviously, we'd love to talk about that, but we need to focus on what's at hand. 1 minute left. Again, this is the anticipated time to complete the solar array deploy. Mick, I think we did hear that there is a good call on beginning that process.
Yeah, the team is getting some low-rate data, and we did hear from the Spacecraft project that they had begun that project on time. So, as you said, we're hoping here in about 50 seconds to hear that solar array deploy is complete. And as Daryl mentioned, 2 minutes after that, we get full acquisition of signal to check out the health of Lucy. And we should hear that come in from Spacecraft project manager to our NASA launch manager to make sure that Lucy is good.
Yeah, we did get that call. We weren't sure if we would hear a call for beginning solar array deploy because we did kind of, I don't want to say lucked out because there's no luck here, but we were fortunate to get that low rate data. We may not get full confirmation until we do get that acquisition of signal, which although that clock is almost at zero, may not be for a couple more minutes. As we wait here, Mick, communicating back to Earth is a challenge, and we kind of saw a little bit about that from one of our guests talking about when you're close to Earth, it's speed of light, but ultimately it's always speed of light, but that's a lot easier when you're close to Earth. When you're farther away, there's different communication mechanisms.
Yeah, so for today's mission, we actually utilized the TDRS network, the Telemetry Data Relay Satellite Network that NASA owns for the vehicle telemetry and for some of the spacecraft data that we've started. Excuse me. And as Lucy moves on its way out towards the asteroids, we'll take advantage of the Deep Space Network, or the set of ground stations here on Earth that have huge, huge satellites that can pick up the smallest and faintest sound from space. So that is a huge asset that we have within the NASA and aerospace industry to be able to work with satellites that travel this far as Lucy is doing.
Yeah, again, hoping now within a couple minutes to hear from Lucy. I want to emphasize that just because if we don't hear that quickly, that's not necessarily a bad sign. There's a big window here when we know that acquisition of signal might take place. So we will kind of try and stay with you as long as it makes sense. But again, that's kind of the nature of spaceflight. Again, it's not about luck. It is about science, and there's lots of factors at play.
Yeah, like I said earlier, the team has done a great job of designing this trajectory and working, and so far all the predictions have been right on target. So as the spacecraft team works through their thing, their steps, there is another 20 minutes roughly that we could get signal, or it could go as late as hour 55 after liftoff. So we'll stay around and look at what's going on, but the team is definitely still looking at that and working it. Joshua, I did want to go back. You had asked me earlier when we were off air about spacecraft separation. and how simple that was. And it was, basically
it looks simple.
It looks simple, but it's an engineering feat, and it uses a Marmon clamp that's been around for years. And the Marmon clamp has an explosive bolt that is released, and the Marmon clamp releases, and Lucy was actually pushed off the front end of Centaur with 6 separation springs. So that's it sounds very easy, but it's actually a very cool engineering design that allows us to be able to keep the spacecraft on there for the ride and then separate where they need to go. So I wanted to bring that back for the folks on that are watching us. I think that's just a cool engineering thing that happened in the mission today.
Yeah, appreciate those tuning in. Again, we had successful liftoff on time this morning at 5:34 a.m. Eastern Time, and we are standing by now hoping any second to hear that Lucy is alive and well. But as we wait, thinking ahead to what's to come, Lucy again headed to 8 asteroids around the solar system, 1 main asteroid belt, and then 7 Trojan asteroids.
Yeah, and this is just the beginning, as we've said earlier, right? The team will get the solar arrays out, they'll get acquisition of signal. They've got a lot of work to do on orbit, testing out the systems, making sure that their batteries are charged, making sure everything's working. As I mentioned earlier, they're very efficient power usage, 5,000 watts. So they want to make sure all that's working as they're traveling towards these asteroids, so that when they get there, that everything works in the sciences. So they'll do checkouts of all the instruments that we talked about on the show today. And the team, the spacecraft team, still has a lot of work over the next few months and years, 12 years, right?
Yeah.
So that's what's coming for the spacecraft team. We just saw a little bit ago, we're still focused on Lucy, but the LSP team is beginning to work with our other commercial partners on some missions. Another asteroid mission, DART, which is a very cool mission that we're going to send a spacecraft to an asteroid and try to impact its trajectory a little bit. So that's looking forward to that mission coming up here very soon. So.
Yeah, and looking ahead to Lucy's journey, she's if you're ever frustrated by your cell phone not working in a timely fashion, and you're kind of anxious to hear us get this call, a reminder that Lucy's now hurtling away from Earth at greater than escape velocity, which means more than 25,000 miles per hour away from Earth. So this is much more complicated than even a simple text message that you just can't get to send.
Yeah. No, the teams are definitely paying attention, looking at all the stuff they've got, and watching that the automation on the spacecraft is working. Definitely can tell you that there's probably a little tense moments going on right now from that aspect. But we are still waiting to hear if we hear around us some clapping, but I'm not sure what that's for yet. But we are waiting to hear from the spacecraft project manager to the NLM on acquisition of signal. So hopefully we will hear that soon from the team. But definitely something is going on. There's some happy and clapping going on here. I feel like I'm a little in the dark, right? So
that's right.
That's good. But we'll hear that hopefully very soon from our NLM.
So, Mick, as we look ahead to this process, again, the speeds we're talking about here are pretty exceptional. Lucy will get up to a maximum speed of about 400,000 miles per hour. A lot of that has to do with these gravity assists that they'll get the slingshot effect from Earth, hurtling towards the Trojan asteroids, which are in the same orbit that Jupiter follows. All right, so I'm seeing lots of applause. I'm hoping that's a good sign. We haven't heard the word come in yet.
So yeah, I just saw a movement that solar arrays
are
completely deployed. So that's a good thing for the spacecraft team. Solar arrays are completely out, and so now we're just waiting on acquisition of signal from the team. And Joshua, as we said, these things they ran some analysis, and there was some time frame here, and they're within their time frame. So not necessarily anything happened bad here, but it's going well so far for the Lucy spacecraft. So we'll wait to hear that they get that acquisition of signal and determine the final health of the Lucy spacecraft.
Yeah, the orbit that we're taking is a very high elliptical, where it will come around near Earth and then slingshot out into the Trojan asteroids in the same orbit as Jupiter, so that the apogee of that orbit would end up being kind of the slowest point of of Lucy's motion, and Jupiter and the Trojans move at a speed of roughly 29,000 miles per hour in their orbit around the sun. So that kind of gives you a sense of the incredible speed that you have to build up so that at your slowest point, you're doing that. So again, an incredible just trajectory and engineering feat to be prepared to rely on Lucy to fly freely for 12 years. That's something that a lot of people might have a misconception about, is that Lucy's not under powered flight for 12 years.
Yeah, that's true. I mean, it's not like they can change trajectory during this time, right? We have put them on a where they needed to be by the specific designed trajectory it needs to be. And with those massive solar arrays out there, they can't make very many, they can't make any maneuvers out there. So Lucy is on her way with solar arrays deployed, and things are going well so far. We're just still waiting to hear. Like I said, we keep hearing some clapping in the background that we know that some of that is solar array deployment, and we're just waiting to hear that they've acquired signal of the spacecraft, and we'll go from there.
Yeah, and it's looking like that word is in. I noticed there the folks in that room that you're seeing on screen have taken off their headsets. That is usually a sign that we are good to go here. So I believe we're good. We're going to send this out to Daryl now. So Mick, that's going to do it for you and me here. Appreciate you riding along with me, Mick. Until next time.
Yeah, Joshua, thank you. This was an exciting mission. Very happy for the spacecraft team so far and the launch LSP and United Launch Alliance teams. Looking forward to our next mission, DART.
Awesome. Signing off from the ASOC, Daryl, back to you.
Thank you, Joshua and Mick. And in the upper right-hand part of that picture, it was nice to see Hal Levison and Danya Douglas Bradshaw celebrating the big moment of acquisition of signal.
Yeah,
Huge.
Finally able to breathe a sigh of relief.
Yep.
And now here's a special preview of NASA's next Launch Services Program science mission, launching next month. It's the Double Asteroid Redirection Test.
Looking forward to the DART mission. Got to make those travel plans out to California. We'll have it for you here on NASA TV. For now, though, we want to go back to the NASA launch manager, and he is with our own Franklin Fitzgerald.
Yes, I'm here with Omar Baez, who's the Senior Launch Director for the Lucy mission. Omar, how did things go this morning?
Things were splendid today. Everything went on time as predicted, and I couldn't ask for a better count. It just clicked off the way it should, and we really worked no major issues. So we were able to hit the window at the very beginning on the very first day of the short window for Lucy. So we're happy to be here at this point.
I understand you were wrapping up a few things before you were able to come up. Everybody just got up and left. What does that mean?
That means things are really good. So what that means is both solar arrays have deployed, and we did lock onto the acquisition signal from the spacecraft. So the folks at Goddard and Lockheed Martin Denver are controlling now and have positive control over the spacecraft. So that's the best shape you want to be in.
Right before you came on, they rolled a package talking about DART. That's the next mission for LSP. Can you tell us a little bit more about it?
So that one is so cool for us. DART is going to kinetically hit an asteroid, and it's our second planetary mission from the west coast or Vandenberg. So super exciting. Just a different way of spotting an asteroid, and this time we're trying to go in the aspect of not studying it, but planetary defense. Could we move an asteroid if we needed to? And so this is super cool and a whole different way of operating for us. So we love it.
Omar Baez, congratulations on a successful launch. And are you going to be the launch director for DART?
I will be the launch director for DART. And after DART, we have IXPE from this coast. And that's going to be a cool one for Launch Services Program also, because it's our first KSC launch. We're a program that's been at KSC for 23 years, and we've never launched anything from the Kennedy Space Center, our very first, from Complex 39A.
Oh, that's going to be awesome. We'll be there for that. Hopefully, we'll have you on the show then again as well.
Okay. Thank
Omar
you.
Baez, thanks for being with us today. Guys, back to you.
Omar and Franklin, thank you. And as you look behind us, you see the dawn of a new day. And there's the dawn of Lucy, and her journey to the Trojan Asteroids seems very fitting.
Yeah, what a nice tribute from Mother Earth to Lucy, the fossil and the spacecraft now about to uncover secrets of our beginnings.
Indeed.
So we're going to leave you with a replay of this morning's liftoff, and you can also follow along live mission updates online at nasa.gov/Lucy. Have a great weekend.
And keep looking up. That's my line, Maria.
7, 6, 5, 4, 3, 2, 1, 0. Liftoff. Atlas V takes flight, sending Lucy to uncover the fossils of our solar system.
Tower clear. RD-180 propellant utilization has gone to close.
I have a feather in my right hand,